Are you a chemistry student looking at the difference between compounds as either being an acid or a base and how to show the process of them being an acid or a base? Well, if you have a compound that starts with hydrogen, it is an acid. Acids always, following the modified definition of an acid, the modified Arrhenius definition, donate their hydrogen to water to form the hydronium ion and the anion that's left from the acid. So if you produce hydronium ions because your compound starts with hydrogen, it is an acid. If your compound is an ionic hydroxide, it is going to split into sodium and hydroxide ions. If we produce hydroxide ions, this is a base. So when you have an ionic hydroxide, you simply just dissociate it into hydroxide ions. Now, ammonia is something you have to memorize that acts as a weak base. Now, what ammonia does is it also will produce hydroxide ions, but by taking a hydrogen away from the water. So water is left as hydroxide, and ammonia becomes the ammonium ion. Okay? So again, hydronium ions, acid. Hydroxide ions, base. Hydroxide ions, base. Next, we have something that could act as a base because it's negative and could act as an acid because it has a hydrogen. It's telling us to treat it where litmus paper turns red. So that means we're going to treat it as an acid. So we're going to show how it's going to react with water. If it's acting as an acid, it's going to donate its hydrogen to water to produce, again, hydronium. And the CO3 will be left by itself as CO3 2- since it lost its hydrogen. Now, what if instead we treat it as a base and say that it's turning litmus blue, acting as a base? My HCO3- is now, instead of giving a hydrogen to water, like acids do, it's going to take the hydrogen away from water to leave water, once it loses that hydrogen, as the hydroxide ion, and we now produce H2CO3 as that gains another hydrogen. Okay? So again, hydronium ions, it's an acid. Hydroxide ions, it's a base. Thank you very much for watching.